Hey guys, Mr. Palooza here. Just want to talk you through some practice questions from MathSpace about congruency. So our last video, I went through the congruency proofs, and now we're going to try and use those for some practice questions. So let's get into this. So first of all, two triangles are congruent if they are rotations and or reflections of one another. So it's the same shape, it's just changed in its orientation. So can we match the given information in one triangle with the other? And is this enough to establish congruence? So to be able to say that triangles are congruent, we need to be able to tick off one of these proofs, which I covered in the previous video. SSS, SAS, and just a reminder that the angle in SAS needs to be an included angle, which is in between the two sides, and AAS, which is when two pairs of equal angles and one pair of equal sides, and RHS. So at the moment, we've got two triangles here. Let's see if we can establish some congruence. Now we can say that angle PRQ equals angle SUT. So that one there. So the two yellow ones, okay? SUT. So that's a good start. We can say that angle RPQ is equal to angle UST, okay? So angle RPQ, so that's the blue one. RPQ equals angle TSU. Okay, because that's shown on the triangles. Now the last piece of information given is this 4. But when we look at this properly, the 4, even though it's the same size, it's not the corresponding side. Because in this triangle, the 4 is the side opposite the yellow angle. And in this triangle, opposite the yellow angle, this side is unknown. So that 4 is on a different side altogether. So we don't have a third piece of information. There's no other numbers. There's nothing else really that's given here. So we might not have enough information to determine that these triangles are congruent. Now, you might think, what about the third angle? Okay, that's not one of the proofs. There's no angle proof because we know that 3 angles in a triangle need to equal 180. So if these two are the same size, then this angle is going to be the same for both triangles, but that's not one of the proofs. So the response to this should be, and I have checked this beforehand, so I should know the answer. Let me get rid of the pen. So the answer to this one, it's not SSS because we only get given one side. It's not SAS because we only get given one side. It's not AAS, okay, because the side is not corresponding, okay? It's not the same side that we've established. It's not RHS, there's no right angle. So in this case, we can say they are definitely not congruent because we have not been able to establish any of these rules. If we were able to establish part of one of them, we might be able to say unknown, there is not enough information. But based on the information we have, that 4 is on a different side. So therefore we can say that they are not congruent. All right, let's move on. So which of the two triangles are congruent? Now this is quite tricky here. So the diagrams don't have enough information to determine which two triangles are congruent yet. Now, you might look at these two and think they look the same. There's yellow, there's a 9 and a 5. We're laughing here, but they're actually not corresponding sides. So let me show you what I mean. Opposite this right angle, we've got a number 9, and opposite this right angle, there's no number. The 9 is actually down there. So they are not congruent at all, even though they look similar. So that's where it can be quite tricky, okay? Now, what information do we have here? We've got a side of 5, an angle of 56, and a side of 9, okay? So we might be able to go side, angle, side. Let's look at this triangle. Side, angle, side. We might think, wow, that's really good. We've got it. Unfortunately, there's another bit of information that's kind of thrown us for a loop. And this is this angle here, 34. and 44. So that shows us that these triangles are a little bit different. Now, the sum of angles in a triangle is 180 degrees. So 56 plus 44 is equal to 110. So this angle here is going to be 180 take away 110. So what size is that? That's going to be 70 degrees. So that angle there is 70 degrees. How about this triangle? We've got 56 and 34. Now 34 is 10 less than 44. So we know what this angle here is, okay? 180 take away 56 plus 34 is 90 equals 90 degrees. Now 90 degrees is a right angle, so I can put that angle in there. So now, even though this triangle looks quite different, let's see, opposite the right angle, we've got a 9. What's a triangle that opposite the right angle has 9? It's actually this one here. Okay, so now these two are looking a little bit similar. So can we formally prove that they are congruent? Okay, so this is just explaining what I've just done here. So what else do we have? We have a right angle, we have the hypotenuse equal to 9, and we have a corresponding side next to the right angle, next to the 9, next to the right angle, next to the 9, that is equal to 5. So we can actually say that they are congruent based on the RHS rule, this one here. So that's going to be our answer. All right. There's no side proof because none of the sides is labeled. No triangle has all three sides labeled. It's not angle side angle, even though initially we could have thought, oh, it might be this one, but we had more information that proved that the angles are different sizes. So the triangles are different, completely different. Okay. Remember, congruent triangles are the same. They're just rotations or reflections. All right. So that was pretty tricky. I'm going to skip this one because we're not going to be looking at too many quadrilaterals. So we're going to skip this one for now. Okay, so this question here, we have, it is known that triangle STU is congruent to triangle ABC. So we've already proven it, so we're working backwards a bit. So when two triangles are congruent, the corresponding sides will have the same position with respect to the matching angles. So we need to consider that, okay? So which of the equalities do we know to be true? So let's see if we can figure these out. So TU equals BC. So I'll highlight it as I go. So TU is equal to BC. Now that side there, we have the purple and the green angle, the green and the purple angle. So they are corresponding sides, okay, between the two triangles. So we'll give that one a big tick. That looks pretty good. The second one is US equals AB. So US is here. And actually I should pick a different color, shouldn't I? Let's go green. So US is here and AB is here. Now, the easiest way to look at that one is that side is opposite to the green angle, and here it's opposite to the purple angle. So the fact that they're in different positions means that they're not corresponding, okay? So they're not equalities that we can say are correct. TU equals CA, so TU there, and CA is there. So again, let's look at this. So that one is where the two angles are, the purple and the green. And this side, the purple's there and the green is away from it. So that is not a corresponding side. The last one I'll do in purple. ST equals AB. So ST is that side there, that's opposite the purple angle. And AB is here, which is opposite the purple angle. So that's good because they're corresponding sides. They're in the same position in relation to the angles. So they're the ones that are correct. So next question, it is known that STU is congruent to triangle PQR. And which equalities do we know to be true? So when they're congruent, the corresponding sides, angles, will have the same position in respect to the matching sides. So we can see that angle UST, so UST is that angle right there, okay, is equal to angle RPQ. RPQ. Since both angles are opposite to the side of length 5. So essentially what I'm saying is we know that they're congruent. The 5 is on this side. That's already labelled. So therefore, that opposite angle there is going to be equal to this angle here, which is opposite. So UST and RPQ, that's on there somewhere. UST RPQ. Yep. Now, UST is the same as STU because the T is in the middle. And RPQ is the same as QPR because the P is in the middle. So that one is correct. Which equalities match two corresponding angles or sides together? So, I just circled the answer there. Let's look at this one. Angle STU equals angle PQR. So I'll grab my orange this time. So STU is this one here in orange. And sorry, my cursor's disappearing. Where am I? Here we go. PQR is here. Now, that is opposite to 6, and this angle is opposite to an unlabeled side. So we cannot say that those equalities are true. We don't know that, okay? We're not 100% sure. Because this triangle, the 6 isn't quite labeled. And we could actually figure it out, to be honest. So let's figure that out. The 6 is in between the purple and the orange. So the purple and the orange is the 6. Okay. So if they are congruent, perhaps that is something that we can know. Okay. Okay. So we've got 2 that are actually correct, which is good so far. Let's look at the last ones. So we've got SU equals PQ. So they're sides. So SU is this side here with 6. And PQ is this side here, which is not numbered. We don't actually know the size of that side there. So they are not equal. All right. ST equals PQ. Okay, my last color. We'll go red. So ST is here. That's that unknown side. And PQ is that unknown side here. So that's actually correct. So we've got 3 equalities that are correct and 1 equality that's incorrect. Okay? And we knew that because they were congruent in the first place. Awesome. Okay. These 2 triangles are congruent, so again, we know that. And it says find the value of y. So what angle in triangle STU does the angle of size y correspond to? So let's check this out. So we've got a 90 degree, a 44 degree, and an unknown degree of x. So sum of angles in a triangle, we say 44 plus 90 plus, actually I'll put the x at the front because that's how I like to do it, equals 180 degrees. And then we'll say x plus 44 plus 90 is 134 equals 180. And then we'll say x equals, so 180 subtract 134 is 46 degrees. So we know that that is now 46 degrees. So now let's put that with the matching sides here. So this angle x is in between the 1 dash and the 2 dash. So let's find the 1 dash and the 2 dash. That's there. So basically we're saying angle y equals 46 degrees because that's the corresponding side. Okay. So basically that's the working that I've just put up there for you. And there we go. Easy as. So 2 more. With the given information, which other condition would make sure that these 2 triangles are congruent? Okay, so what's the given information that we have here? We have 2 angles that are 67 degrees. We have a side labeled M, and we have nothing labeled here. I was just going to get a quiet space to finish off a video lesson. Even though they're quiet, I could just, if no one's in here, I might just do it in here quickly. Okay, sorry for that break, and I'm not sure if I've lost my camera, but if I have, I apologize. So this is one of the harder questions. We've got two triangles. Together with the given information, which other condition would make sure that these two triangles are congruent? So what information do we have? We've got two angles that are the same size. Now, what are our 3 or 4 proofs? We've got side, side, side. Now, we don't have any information about sides. So if we have one more piece of information, we'd need 3 more pieces of information for this one. So that's no good. We've got SAS, side, angle, side. Now, again, we don't have any sides, so we'd need 2 more pieces of information. So that doesn't count, okay? Now, just keep in mind, this is based on the information of the question, all right? I'm ruling these out because of what the question is asking me. Which other condition? So it's only one of them, okay? So basically, I have 2 angles. So the information I need is going to be my angle side angle proof, and I need that side, that corresponding side, to make sure that that's the one more thing that I need. RHS is no good because we don't have a right angle, and you can't have a right angle because these 2 angles are 67 degrees each, which when added up equals 144, which means this cannot be a right angle, so that's no good either. Okay, so what's the side that we need? All right. Basically, the side that we could have is, so essentially it's going to be either this one or this one or this one. Now I need to make sure the side is corresponding. So let's see if they're corresponding. EG equals HJ. So EG is this side here, and HJ, makes me hungry, is on that side there. Now EG, it's got one part of the side is next to the 67 and the other part isn't. And on HJ, it's the 2 67-degree angles. So those sides are not corresponding, so that's no good. Let me change my color. So EF equals HJ. So EF is down here, and HJ is the same one. Now that is a corresponding side because you can see the 2 67-degree angles are next, that side is in between those 2 angles, which is the correct here. So this is the correct answer. I'll just quickly check this one. EF is down here. HK is up here. They're not corresponding. That's no good. Cool. So basically, we can say, once we have that, we can prove that the triangles are congruent via our angle side angle proof. The last part is saying, given that EF equals HJ, all right, which is what we already figured out, and EG equals 7, find the value of M, all right? So how do we prove that? Now that we've proved the triangles are congruent, I can say what type of triangle it is, and they are isosceles triangles. Now an isosceles triangle is a triangle that has 2 sides that are the same, and therefore the base angles are the same size. So that's what that is by definition, which is what you've learned in the previous topic. So the 2 base angles, that means these 2 sides, even though we don't know what they are yet, they are the same length. So I'll put 2 dashes there like that. Now it says EF equals HJ and EG equals 7. So let's look at side EG. That's this one here, and that equals 7. Okay, so we can say EG equals 7. What's the value of M? Now, if that side is 7, that means every side with a dash is also 7. Okay, so GF is 7, HK is 7, and JK is 7 because the triangles are congruent. They're isosceles, so by definition, that's going to be the same. So I can say that M is also equal to 7 because we proved that by saying that they're isosceles triangles. Awesome. Guys, thanks for watching. Hopefully this helped a little bit with your congruence questions. I'll see you next time.